Welcome back, mathematicians. This is Miss Prenner bringing you the next video of our unit. So yesterday, either on homework or in classwork, you were asked to find a pattern for this particular series or sequence of numbers, this list of terms. 1, 1, 2, 3, 5, 8, 13, 21, 34. And what you might notice is that 13 is equal to 5 plus 8. And that 8 plus 13 is 21. Or that 13 plus 21 is 34. So it appears to be a pattern where each term, or each number, is the sum of the previous two numbers. So the next term would be 21 plus 34, which is 55, and after that is 34 plus 55, which is 89, and so on. We could keep going. This is called the Fibonacci numbers, and the number of petals in a flower follows this Fibonacci numbers, which means that in nature, we often find that these particular numbers, like 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on, occur or appear in nature. So a lily, for example, has 3 petals. A buttercup has 5. A chicory has 21. A daisy has 34. All Fibonacci numbers. Also interesting is if you look at the spiral pattern of seeds, you might count the spirals of the seeds of a sunflower and notice that there are 34 going clockwise or 21 going counterclockwise, both of which are also Fibonacci numbers. So what's interesting about these number patterns is that they occur in the natural world, and understanding what the patterns are can help us find them. We'll do more of these examples later, but our new unit is on sequences and series. So a sequence is just a set of numbers called terms, arranged in a particular order. So I've written some examples of sequences for you, one of which is our beloved Fibonacci sequence. The next are just some other sequences. Let's see here. We've got 1, -1, 2, -2, 3, -3, 4, -4. You could probably find a pattern from here. Or this less clear one, 3, 3, 5, 4, 4, 3, 5, 5, 4, 3, 6, 6, 8. Some kind of pattern maybe, or maybe not. And then this one, 2, 4, 8, 16, 32, 64. Another one where maybe you can find a pattern. So our key question for the unit is there a pattern? What is the next term? As in, how could I continue the list? Or, how can I find any term? If I want to find any number, let's say I want to find the 1,000th number, how could I do that? Is there a quick way? So the first thing we're going to talk about a little bit is notation. And the notation is the same for all kinds of sequences. The first, term of a sequence is usually denoted T sub 1. That's called a subscript. So this would be called T sub 1. And this is the first term. And each subsequent term is denoted as what we call T sub n. Well, what do you think that means? T sub n is the nth term in the sequence. That is, let's say I have the numbers 1, 2, 3, 4. Oh, I don't want to use these numbers. I lied. Let's go back to the number 2, 4, 8, 16, 32. ... Well, T sub 4 is the 4th term in the sequence. So t sub 4 in this case is 1, 2, 3, 4, 16. The fourth term in the sequence. So this n stands for the term number. It's not the actual term. So again, if I'm thinking about t sub 4, this is the fourth term. So n says where on the list you are. It's a location. And t sub n is what your value is. So it's the actual number in the sequence. Right now, we're going to start by talking about recursive formulas or recursive definitions. Our goal is to find patterns recursively. So a recursive sequence or a formula describes the function or describes the sequence. It gives us a pattern in terms of prior terms of the sequence. That sounds kind of confusing. It's in terms of prior terms. But really, to define a sequence recursively, we just need to know two things. T sub 1, which is where you start. And then a formula for t sub n in terms of prior terms, such as t sub n in terms of t sub n minus 1. Recursive definitions or recursive formulas are a little bit like climbing a ladder. So t sub 1 is like getting on the first rung of the ladder. And t sub n, this formula, tells us how to get to the next step from where we are. So here's an example. We have 3, 7, 11, 15. So I know that this is plus 4, right? So 7 plus 4 is 11, 11 plus 4 is 15. So our pattern is add 4 to the last term. All right, and we're going to start at 3. So t sub 1 is 3. And then we're going to say, to get to my next term, I'm just going to take my prior term. So if I want to get to t sub n, I'm going to start the term right before it, t sub n minus 1, and add 4. Well, if I try this, t sub 1 is 3, because I said so. T sub 2 is going to be 3 plus 4, because that's t sub 1 plus 4, which is 7. T sub 3 is then t sub 2 plus 4, which is equal to 7 plus 4, which is equal to 11, and so on. So you find each term by doing something to a prior term. So here's another example of a recursive sequence. And I want you to write the first 5 terms. So it says that t sub 1 is 3. I need to find t sub 2, t sub 3, t sub 4, and t sub 5. And the pattern is 2 times the prior term plus 1. It's going to be 2 times t sub 1 plus 1. Or 2 times 3 plus 1. Well, that's 2 times 6, which is 7. T sub 3 is then going to be 2 times t sub 2 plus 1, which is 2 times 7 plus 1, which is 15. T sub 4 is 2 times t sub 3 plus 1, which is 2 times 15 plus 1, which is 31. And t sub 5 is going to be 2 times t sub 4 plus 1, which is 2 times 31 plus 1, which is 63. So our sequence so far is 3, 7, 15, 31, 63, and so on. Dot, dot, dot means and so on. What would T n minus 2 stand for in recursive formula? It would be the second to last term, right? Or the nth minus 2 minus 2, or the n minus 2th term. So if I have t sub n here, let's say I have a list, I have t sub 1, t sub 2, and I go all the way up to, I want to go all the way up to n, t sub n. Right before t sub n is t sub n minus 1, and before that is t sub n minus 2. There you go. So that's how that would look if you wrote it out as a list. So here's an example using that. Write the first 5 terms of the sequence t sub n equals 2 times t sub n minus 2 plus t sub n minus 1. Well, we can't do that because I wasn't given, not given, starting terms. But suppose I was. Let's say I'm going to need 2 of them in this case because I have 2 recursive pieces. So you're going to need at least 2 to start. Let's say t sub 1 is 2 and t sub 2 is 3. Well, now I could do it. So t sub 3 is 2 times what is 2 terms ago. So t sub 1, 3 minus 2 is 1, plus t sub 2, which is 2 times 2 plus 3, so that's 7. A lot of 7's coming up today. T sub 4 is 2 times t sub 2 plus t sub 3, because 4 minus 2 is 2, 4 minus 1 is 3. So that's 2 times 3 plus 7, 6 plus 7 is 13. And t sub 5 is 2 times t sub 3 plus t sub 4, which is going to be 2 times 7 plus 13, which is 14 plus 13, or 27. So our formula is, our pattern is 2, 3, 7, 13, 27, dot, dot, dot. I don't know why that repeated. I apologize. All right. So let's try a couple more. So write a recursive formula for the sequence, and this was on a worksheet earlier. Let's say your first job out of college gives you these 2 options. We just want to write recursive formulas. So option A is every year you gain $1,900, right? So we're going to do A and over here. So we'll say, so I need a t sub 1 and a formula for t sub n. Well, it says my starting salary, that's going to be my first year's salary, is $60,000. And then the pattern is start at 60K and then add 1,900 per year. So it's going to be take my old salary, my last year's salary, and add 1,900. So that's A. For B, it says start at 60K and then multiply my salary by 1.03. That's going to be an increase of 3% every year. I'm adding 3% of my salary back in. So it's going to be t sub 1 is the same $60,000. I really should write that out, sorry. And then T sub n is T sub n minus 1 times 1.03. You could also consider that T sub n equals T sub minus 1 plus 0.03 of T sub n minus 1. But these are equivalent formulas. And then what if you get both options? You get the 3% increase and a $1,900 bonus. Let's make that a concept check. Try to write the formula or the recursive formula for this example. All right, so this last problem says, give the first 8 terms of a sequence. Again, pause and do the concept check and then come back here. Give the first 8 terms of the sequence defined recursively by this formula. All right, well, T sub 1 is 4, T sub 2 is 8. Looks like I'm going to take my last term divided by my second to last term, so it's going to be 8 over 4. And then, I'll actually write that out, so that's 8 over 4, which is 2. 2 over 8, which is 1/4. 1/4 divided by 2. 1/8. Yep. 1/8 divided by 1/4 is 1/2. 1, 2, 3, 4, 5, 6. And then 1/2. It's going to go to 4. And then 4 divided by 1/2 is 8. Oh, and then it looks like it would just repeat, right? Because I'm going to have 8 over 4. 1, 2, 3, 4, 5, 6, 7, 8. Or 8 over 4, which is a half again. So I need a little more than 8. But this is our first 8 terms, I think. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, well, I notice a pattern. It repeats every 6 terms or so. But observing the pattern you get from above, what do you think the 1,000th term of the sequence would be? I really don't want to write this. And that is sort of the flaw of recursive sequences, which is that in order to list the next term, I have to know all the prior terms. That's kind of annoying. For this problem, though, I notice that the pattern loops. So I know that like T1 is going to be the same as T7. I notice T2 is the same as T8. So it loops every 6 terms. Which is to say that there are 6 numbers and they're going to constantly repeat. So what I think I could do is just figure out where in the list I'm going to be. So if I take 1,000 and divide it by 6, I should know how many loops it makes and then figure out what's left over. So 6 goes into 10 once. That's, whoops, I can divide to everybody. It's clearly been a long spring break. That's 6 divided by 4. So 40 goes into 6, 36, 4. And we're going to do that again. So I know that I'm going to have 166 loops around my pattern of these 6 numbers that are just going to keep repeating, plus 4 more. Which means that if this is term 1,000th And this is T sub 999, T sub 998, T sub 997, and T sub 996. I know that T sub 996 is going to be that 1/2, because that's this quotient of loops, which means that's going to be 4, 8, 2, 1/4. So I could figure out with a little bit of puzzling that because my pattern repeats, my sequence has a repetition in it, I could just find how far into that pattern I was going to be. But that's kind of tricky. Maybe if I had Google spreadsheets, I could have done this faster. All right, so our last concept check is just a reminder about T sub n versus n. So T sub n stands for the nth term in a sequence. N stands for the term number, not the actual term in the sequence. So if the third term in a sequence is 8, tell me what is T sub n and what is n. I hope this video helps. I hope that you were able to follow along. Again, I look forward to seeing you if you have any questions. Have a great day and make